Hello, I received your question about these problems. I thought I'd work this part and maybe leave the last part to you here. In recent years, normally you have some scores normally disputed and you're given a mean, which is real important, 20.5, and a standard deviation, 5.3. You want to compute these parts. You want to find the probability a student has scored between these two scores. Well, you need to find the z-scores, and the old-fashioned way is to use the table. You can also use a calculator, which would make short work of this. But if we go the old-fashioned way, I guess, let's see, find the z-scores. Let's see, z-score equals the score you have minus the mean over standard deviation. And so one of these z-scores would be, if I start with the 15.8 minus the mean, and if I divide that by the standard deviation. Let me go over where I get those numbers from. Here's the standard deviation, and here's the mean and standard deviation, the mean and standard deviation, and then here's the given score. And let's see, I've already punched that in the calculator, and I've rounded to the nearest tenth, and I get a minus 0.89. Now that number is rounded. If you do on the calculator, it'll be a little more precise, but the computer will accept this answer that you get using the tables also. And so I need to find the z-score for the other one. So if I do this again, z equals, let's see, the other score is 25.2 minus the mean, which is 20.5, over standard deviation, which is 5.3. And here I get a z-score of positive 0.89. Again, that's rounded. That's positive 8.9. So, I'm using this score, 25.2 minus the mean, all divided by standard deviation here. And I get a positive 0.89. And at this point, you need to go to the tables in the appendix of the book. I don't have the book here at home, so I'm just looking at, I open up the appendix. You can look at the appendix electronic book online. So what we have here is we have a normal curve here. I can't draw too well on the iPad here, but I guess the mean is 20.5, and so right here in the middle is 20.5, and we're one standard deviation. Hold on a second, somebody's talking to me. So we have one standard deviation below the mean, and so we got a minus 0.89. We got one standard deviation above the mean, which, this is the z-scores, not the actual score. And so we want to find the area between these two. We want to find this area here. Well, when you use the table, it'll find this area here to the left for this z-score. Then it'll find, for this z-score, it'll find the area to the left. And so if we subtract, what we have in the table here from this one, then that's what we need. So I went ahead and looked these up in the table, and for this one it came out to the area under the table, the normal curve was 0.1833, and then the other one was 0.1867. And so that'd be the probability, or that's probability or the area under the curve. So the area under the curve from here to the left is the 0.1867. The area, the negative 1.89 here. Then from the positive 0.89 z-score, the area from here to the left is 0.8133. We want the difference in those two. And so 0.8133 minus 0.1867, that gives us a difference of 0.6266. Now, this is from the tables. The computer will accept that. If you use like the technology, you'll get a little more accurate answer. Hope this helps.